Mrs. Miller's class. We are in our game show mode right now. So here we go. We are doing scientific notation today. We have our lovely studio audience. Lots of wonderful contestants out there that are going to come up and show us some really great math things. So here we go. Let's do a review of scientific notation. How many people are taking chemistry this year? Okay, for our viewers at home, that's most of the audience is taking chemistry. So how many people in chemistry have started scientific notation already? Okay, so that's scary because there were only like 3 hands, but you're all taking chemistry. So how is it that only 3 of us have been? Okay, so let's do a quick review here. Okay, scientific notation. So people who were paying attention in chemistry, because clearly only half of us learned the scientific notation from chemistry. Who can tell me what the point of scientific notation is? Sloan.
Moving your decimals.
Okay, you're moving decimals, but what's the point? Why? What is the point? Liz, right? Vanessa.
So you can, convert formulas.
Okay, so you're converting numbers. Excellent. Michael? Perfect. Okay, it's a way to write numbers so that you can represent really big or really small numbers. So it's a way to represent very large or very small numbers. Okay, so here is the game that we play in this class. We go through our notes, and at the end when we do our examples, we have contestants come up and test whether they understand the concept of scientific notation and all of the other things that we learn in this class. This is going to be great, right, you guys? Yay! Yay. Okay. Awesome. All right. 10 to the end. All right, so scientific notation. Scientific notation is in the form a times 10 to the nth power. So let's review what each of these mean. A represents a number that is, so it's a number. Can you guys read the purple? Mm-hmm. Greater than 1 and less than 10. Okay, n represents an integer. Okay, so integers, remember integers go from negative infinity all the way to positive infinity. So I'm just going to put a few of them over here. Negative 2, negative 3, negative 2, negative 1, and on and on and on. Whoops, 1, let's do 1, 2, 3, on and on and on. Does not include 0. You can't have times 10 to the 0 power. Okay, so let's do a really quick example here. If we're going to put something into scientific notation. So let's do 1, 2, 3, comma, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, we'll stop there. Okay, I was getting into a beat there, but you guys weren't going with it. Okay, so if I wanted to write 123, I don't even know how many that would be, quite a few, in scientific notation, can somebody direct me? How would I do that? Make sure you can see that. Thane. Come up, not this time. Just direct me for right now. And then, as your host, I feel the need to direct people first, and then contestants can come up afterwards. Go ahead.
All right, so what you need to do is you need to count the number of zeros, and then make that 10 to the amount of zeros place.
Ah, good. Okay, so Thane says we count the number of zeros. How many people agree with Thane that we count the number of zeros? Okay, is it just the number of zeros, or do I count some of these as well?
Yes.
You count, how do I figure out, so how do I figure out where the decimal is supposed to go? Rebecca.
Well, the number has to be greater than 1 and less than 2.
Good.
When you move the decimal, you have to make sure what's left of the decimal is greater than 1.
Perfect. She said we have to make sure that wherever we put the decimal, the number we end up with out here is greater than 1 and less than 10. So where would I have to put that decimal in these numbers? Aiden. 2 and the 3? That would give us 12.3. Is 12.3 less than 10? No. That's good. In between the 1 and the 2. And then we count the number of spaces from this decimal all the way to the very end. So are you guys ready? You gonna count with me?
Yeah.
You ready? Here we go. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There is a 0 there. So that's times 10 to the 20th power. What goes here? Who can tell me what goes here? Olivia. Perfect. 1.23 times 10 to the 20th. Woo! Nicely done. Everybody give all of our volunteers a round of applause for that. Questions on that one? Okay. Let's do one more, and then we will get to our examples. Contestants, be on your feet. What I could do, too, is have a hat up here and pull people's names out.
Yes.
Or we don't have to do that. Okay, here we go. Ready? 0 point. Everybody get ready. What if I get into a beat? You guys gonna go with me? Okay, 0 point. 0, 0, 0. 0, 0, 0. 0, 0, 0. 0, 0, 0. 0, 0, 0. 1, 2, 3.
4.
Okay. Now. Let's count that. Here's an easy way to count zeros, you guys. If you put lines on the top of the zeros in groups of 3, that helps count. So like here's one group of 3, 6, 9, 12, 15 zeros, okay? 15 zeros. Does that mean, though, that I'm going to have what did I say, 15? Does it mean I'm going to have a 15 here? Not necessarily. Okay, so where do I want to put the decimal in this thing? Jiro. In front, right here?
Wait, like, when you're multiplying the
Uh-huh.
Yes.
So if I put it right here, the number I end up with is 0.123. Is that greater than 1?
Wait, no, you put 1, 2, 3 times 0.1.
Okay. So I'm going to put 1, 2, 3 times, it has to be 10 to some number. So, what do we think? Should it be 123? No. Oh, I like that. No deal. Okay. Alyssa, go ahead.
You put the decimal
In between the 2 and the 3? If I do that, I end up with 12.3. Is 12.3 less than 10? No. The 1 and the 2. Excellent. Okay, so it should be 1.23 times 10 to some power. How do we figure out what number goes up here in our exponent? Good. Count how many it's from the original decimal place to where we put it. You guys ready? Okay, I'm going to go from this direction. We're going to right here. So ready? Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Now, is it times 10 to the positive 16? No. Negative. Why is it negative? Who can explain why it's negative? Let's see. Do you want to do it, Tyler? Okay. Go ahead.
Moving to the right and moving away from, like, where
Oh, good. I like that. Okay, so you're moving kind of away from where the original decimal place is. That's a good way to think that. Away from negative numbers or something. That's good. Okay. Anyone else have another way of explaining it that they like to volunteer? Cole? Good. When the zeros are to the left of the numbers, then you're going to have a negative exponent. If the zeros are to the right, then you end up with a positive exponent. Excellent. Questions? Okay, contestants, get ready. Here we go. All right. Here is our first example problem. Be thinking about whether you want to come up here and show us all how it is done. Convert to decimal notation. Oops, sorry. Convert to scientific notation, not decimal yet. Okay. So the first one we're going to do is 47 billion. I'm going to put a few of these up here so you guys can look ahead and be on the lookout if you would like to try putting these in scientific notation. Okay, so that's the first one. The second one, can you guys see okay? Second one is 0.000000016. 0.0000016. Okay. Everybody take a look at those. All right, is there anyone who would like to come up and show us how to put 47 billion into scientific notation? Aiden, come on up. Everybody give Aiden a round of applause.
Which, do I use any pen?
Yeah, pick one of the kind of this kind. Yeah.
Okay.
Okay. The crowd is suspenseful, waiting for Aiden to put up his answer.
Okay, so
Everybody, what's he gonna do?
like,
You just have to keep on reading. We don't want to pass out. That will not be fun. We should come up with you know Jeopardy while you're waiting for the answer. It's
Make changes for like the TV version, right? Rock when it's just distracting.
Okay, so that's another thing to be thinking about, is come up with some sort of Jeopardy-ish, or waiting for the contestant to finish their work song. I will play, I think I have it on my thing, the song that people made. It's funny. Okay, what is that?
Oh.
4 points. So, everybody, Aiden, what did you come up with for your final answer?
4.7 times 10 to the 10.
Is that your final answer?
I hope so.
So, how many people agree with Aiden?
Yeah!
Woo! All right, everybody give Aiden a round of applause. Thank you, Aiden. All right. Yes. Aiden wins the knowledge of how to put a number into scientific notation. Woo! All right. 4.7 times 3, 6, 9, 10. Good. Okay. Next one. 0.0000016. Rebecca. Everybody give Rebecca a cheer her on. Rebecca. Woo! Okay. So everybody should be thinking about how they would write this number in scientific notation. We do the Jeopardy song temporarily while we're thinking of a new one. How many people watch Jeopardy? How many people don't want to sing? How many people are kind of embarrassed that we're doing this? Nobody is raising their hand. Okay, so she got 1.6 times 10 to the negative 6. How many people agree with Rebecca? Okay, woo! Good job! Give Rebecca a round of applause. Nicely done. Okay, now we're going the other direction. Convert to decimal notation. So now we start with scientific notation and we want to write it as they started out with in the last problem. So convert to decimal notation. So that's the non-scientific version. Okay, so decimal, that's good. Okay. So, here we go. 4 times 10 to the negative 4th. Let's move this up so you all can see. 4 times 10 to the negative 4th. And the second one is 6.73 times 10 to the positive 8th. 4 times 10 to the negative 4th and 6.73 times 10 to the 8th. For our viewers at home, I'm going to go ahead and take a short break, and we will be back with our next contestant. All right, we are back, and we have contestant number 1, Olivia, is going to come up and show us how to do 4 times 10 to the negative 4th, and then we have lucky contestant number 2 to do, Alan is going to do number 2. All right, here we go. Woo.
Wait. Oops. My bad. I messed up. Okay.
Should we do the song? calculation. Woo! Nice. All right. Alan, come on up. 6.73 times 10 to the 8. All right. Let's do the song louder this time. Ready?
Do 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 do
Bum,
do
bum,
do
bum.
do.
Bum, 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 bum. Bum, 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 bum. Bum, 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 bum.
All right. Whoa, hang on. He has an answer. Let's stick some commas in there.
Oh, yeah.
And scoot it up a little bit so we can see. So you're off the screen. That's better. Okay, so what is your final answer? How would you say that?
673 billion.
That's close.
Million.
Million.
Yeah.
Yay! Thank you, Alan. All right. Last two problems. Here we go. So this is the calculator part. Raise your hand if you have your calculator with you. All right. Everybody has it out, I hope. If not, go ahead and get it out now. So here we go. No, we are multiplying, dividing, and simplifying. So multiply or divide and simplify. So here we go. The first one, 2.3 times 10 to the 6th. I'm going to walk through one of these with you, and then I will ask for a contestant on the second one, okay? 2.3 times 10 to the 6th. We're multiplying that by 4.2 times 10 to the negative 11th. So 2.3 times 10 to the 6th times 4.2 times 10 to the negative 11th. Okay, so here's how we're going to approach this problem. What we want to do is we want to group together the like numbers. In other words, the ones that have 10 as a base, we're going to group those together over here. And then the other two we're going to group together in the front. So we're going to do 10 to the 6th, 10 to the negative 11th on that side. And then on the other, the left, we're going to group together 2.3 and 4.2 and multiply them separately. That green is kind of hard to see, huh? Okay, so let's see. Over here we have 2.3 times 4.2. All right, so everybody on your calculator. So just a heads up, you guys don't get to use calculators on tests, okay? So you do want to know how to do multiplication problems like this, but for now, if you want to review that, we can do that. For now, on your calculators, if you multiply 2.3 times 4.2, what do you end up getting? 9.66. Good. Okay, now from the last couple days, 10 to the 6th times 10 to the negative 11th.
Is 10 to the 100 to the negative 5th power.
That's so close. 10 to the negative 5th power. Excellent.
100.
Yeah. So remember, you keep the base the same, but add the exponents. Nicely done. Okay? Questions on that? Would we like to review how to multiply these without a calculator? Yes? Okay. So let's see. 2.3, 4.2, one on top of the other. 3 times 2 is? 3 times 2 is? 3 times 2 is? 3 times 2 is?
6.
That's good. 2 times 2 is? 4 times 3 is? 12. Carry the 1. 4 times 2 is? Plus 1 is 9. Good. Now if we add straight down, we get 6, 6, 9. And I move the decimal over. If I look over here, there are 2 numbers that are behind decimals, which means I take my invisible decimal here and move it over twice. Okay? So it's 9.66. All right. Next. So this is one where I'm going to ask for a volunteer. All right? 4.0 times 10 to the negative 6th over 8.0 times 10 to the negative 3rd. That's a 3. So this is same exact concept. You're grouping things together, but instead of multiplying, you are dividing. Okay, 0.0 times 10 to the negative 3rd. All right, we are going to take a short break and be right back. We have our next contestant, Tyler, who is going to show us how to do something like this. So, there you are, sir. Go right ahead. So Tyler's going to walk us through the correct solution to this. Guys want to do your music? No, I'm getting tired. Okay.
Let's just have a
A hum.
That sounds kind of weird.
All right, how many people agree with Tyler? He's got 5 times 10 to the negative 4. All right, everybody give Tyler a round of applause. Thank you, Tyler. Okay, so let's just recap real fast. The reason that we had to turn 0.5 into 5 is because scientific notation says this first number has to be greater than 1 and less than 10. 0.5 is not greater than 1, so we changed 0.5. Tyler changed 0.5 into 5 times 10 to the negative first, and then went through and combined those two. Nicely done, Tyler. Okay, any questions? Yes, Sloan. Okay, did this one make sense?
Yeah, that one makes sense.
Okay, so you're doing the same thing. 4 divided by 8 is 0.5. And then this one you do subtraction, negative 6 minus negative 3. So negative and a negative become a plus. And negative 6 plus 3. So if I start out at a negative 6, my day starts out at a negative 6. At 6, it's a really bad day. But if 3 good things happen, I'm now at a negative 3. So that's where that one comes from. So does that part make sense?
Yeah.
Okay, everybody's... Okay, then from here, remember scientific notation, the definition says that you have to have a number here that's greater than 1 and less than 10. Okay, 0.5 is not greater than 1. So we have to make it a number that's greater than 1. The way that we can do that is to write 0.5, putting the decimal right here. So 5.0 times 10 to the negative first. The zeros are to the left of the number, so it's negative first. And then we still have that 10 to the negative third on the end. So when we go back and combine these two, and add the exponents, negative 1 plus negative 3 is negative 4. So we have 5 times 10 to the negative.
No, never mind. But you said that.
Does that make sense?
Yeah, I was just wondering why we're leaving as a 10, negative 4.
Yes.
That you can't leave a negative.
Oh, you can, no, you, oh, okay. In scientific notation is the only time you can do that. Sloan had a really good question. She said, I thought that we couldn't have a negative number in our exponent. Very good question. And the only time that you're able to do that is in scientific notation. That is the one specific time where you're allowed to have negative exponents. Very good question. Thank you for that. Other questions? Yes, Aiden.
What's the difference between scientific notation and decimal notation?
Scientific notation is where there are the very specific rules, like this number has to be greater than 1, less than 10, and it's times 10 to the some number. Decimal notation is not like that. So decimal notation does not have that format. It's just any number ever. Like all numbers that we know are decimal notation. Okay, other questions? Very good question. Thank you. All right, so let me list your homework up here. Let's see, this is homework number 5. Page 47, numbers 4 to 64, multiples of 4, and here we go. This is the big part. Study 4, the Chapter 1 group test. You have a Chapter 1 group test tomorrow. Chapter 1 group test tomorrow. Make sure you study for that. Okay, until next time, have a nice day.